per second. Okay. If the current flows for t seconds, look at this. This is the amount of work done in an electrical circuit in 1 second, V times I. If the current flows for t seconds, what is the total energy in the electrical circuit? This is the energy that is converted from electrical to other forms in 1 second. Therefore, in t seconds, the total energy will be VIT. That will be, if I write V using Ohm's law, V equal to RI. So that will be RI times IT equal to RI squared T. When a current I flows through a resistance R for a time T, the energy used up in the resistor is RI squared T. And when a current flows through a resistor, the energy used up becomes heat energy. Is that right? Yes? You see, energy is needed to drive current in an through a resistor because there is resistance for the flow of current. If there is no resistance, then there is no need for any energy spent. So energy spent in driving a current I through a resistor R is RI squared T, where T is the time during which the current flows. And I can also write it as V squared over RT. How did I do that? I can write I. Look at this equation. Energy equal to VIT. Use Ohm's law to write I as V over R. So that will be V times V over R becomes V squared over R times T. So look at the three forms of the energy equation. The energy in an electrical circuit when current flows for a time t seconds is VIT, which is the same as RI squared T, which is the same as V squared over RT. Three different forms of the same equation. Heat generated in an electrical circuit when a current I flows in a resistor R for t seconds. In a resistor, all this energy becomes heat. So heat generated, Q, we generally call the quantity of heat. Q equal to RI squared T. Now, we all pay for electricity consumption, don't we? Why? Because we are using electrical energy. We are consuming electrical energy. We use electrical energy to cook our food, to warm our water, to run our air conditioners, to run our televisions and computers, to iron our clothes. Well, the list goes on and on. We consume electrical energy and we pay for it. Electricity consumption is measured in a unit called kilowatt hour. It is called one commercial unit, and you pay for that. Do you know how much you pay for 1 unit of electricity? Well, if you don't know, ask your parents. They might know. Well, okay, I'm going to leave it for you. Now, what is 1 kilowatt hour? How much energy is 1 kilowatt hour? 1 kilowatt hour, which is 1 unit of electricity, is a measure of the amount of energy consumed at the rate of 1000 joules per second. 1000 joules per second is a kilowatt. Now, if you use energy at this rate for 1 hour, that is a measure of 1 unit of electricity. For example, suppose you have a bulb rated 1 kilowatt. What does that mean, a bulb rated 1 kilowatt? Well, normally we have bulbs rated 40 or, is that right, 40 or 60 watt. What is the power rating of this bulb? This says 40 watt. What does it mean? It means when you connect this to the power supply, it will use up energy at the rate of 40 joules a second. Suppose you have a bulb that is rated 1000 watt. 1000 watt is a kilowatt. Now that bulb will use up energy at the rate of 1000 joules every second. Now, you turn that bulb on for 1 hour. The bulb is using energy at the rate of 1000 joules per second for 1 hour. And that amount of energy used by the bulb for 1 hour is what we call 1 commercial unit of electricity. And you know, you pay for that much of electricity about 10 cents. And that much is called a kilowatt hour. That is, 1 kilowatt used for 1 hour is a kilowatt hour. So can you tell me, how would you calculate the number of units? Tell me, if you have a water heater that is rated at 2 kilowatt, that means that water heater will use 2000 joules of energy in 1 second. Alright? If you have that 2 kilowatt water heater, if you turn it on for 2 hours, how many kilowatt hour do you actually use? What all you need to do is multiply the power in kilowatt by the time in hour. So 2 kilowatt multiplied by 2 hours is 4 kilowatt hour. You will consume 4 units of electricity. So 1 kilowatt hour is energy used at the rate of 1000 joules per second for 1 hour. 1 hour is 3600 seconds. And that is 3.6 times 10 to the power 5 joules. This much of energy is what is called a kilowatt hour. And it is very easy to calculate the number of kilowatt hours. What all you need to do is multiply the power in kilowatt by the time in hour. That will give you kilowatt hour as we normally read it. For example, a 100 watt bulb burning for 5 hours. How many kilowatt hour is the power it consumes? First of all, write the power in kilowatt. 100 watt is 0.1 kilowatt. Multiply that with the time in hour, and that will be 0.5 kilowatt hour. So a 100 watt bulb burning for 5 hours consumes half a unit of electricity. Let's do an example. What is the current in the filament of a 60 watt bulb when connected to a 110 volt supply? Well, we know the power. The power of the bulb is 60 watt. What is the equation for power? Well, power is 60 watt and the voltage is 110 volt. Do you remember the equation we developed for the power? Power is V times I. Don't forget that. V times I. And we know the power, we know the voltage, therefore we need to find the current. What is the current? I equal to P over V. That will be 60 watt divided by 110 volts. That is 0.55 ampere. Another problem. What is the cost of operating a 500 watt electric heater for 20 hours if electricity cost 8 cents a unit? Well, first of all, you need to figure out the number of kilowatt hours. The power given is 500 watt. Write it in kilowatt. That is 0.5 kilowatt. And how many hours is it used? For 20 hours. Therefore, how many kilowatt hour are consumed in here? The number of units equal to power used in kilowatt multiplied by the time in hour. So that will be 0.5 kilowatt multiplied by 20 hour, that is 10 kilowatt hour. And this is what we call one commercial unit. And each unit costs 8 cents a unit. It now costs about 10 cents a unit. So the cost is number of kilowatt hour multiplied by the cost per unit. That will be $0.8 is the cost of using that equipment for about 20 hours. Next example. A 10 volt battery is connected to a 120 ohm resistor. Calculate the power delivered to the resistor. Well, you know the power equal to VI. You can also write it in terms of RI squared or V squared over R in many forms. So we have V equal to 10 volts and the resistance R equal to 120 ohm. We need to find the power V. V power equal to P equal to V times I. But we don't have I. What do we do now? Well, I can write I as V over R. Is that right? Use Ohm's law to rewrite your I equal to V over R. That means the power now equal to V squared over R. Now that will be 10 squared over 120. That is 0.83 watt. And I will get back to you with the next lesson a little later.